Hello everyone, welcome to this session of Cloud Coaching. We are going to discuss data lake modernization. It is part of a series on analytical data platform, which you know is core to the Oracle Cloud strategy. In fact, our mission statement, which is to help people see data in new ways, discover insight, and unlock endless possibilities, says it all. My name is Ismaël Hassane, and I am a design specialist for the analytical data platforms, and I will be your host for the next half an hour. So today's agenda consists in 3 points. What does it look like? The first one consists in defining the data lake. We are going to see what is it. On the second point, we will put a finger on the potential challenges of your current data lake and determine the benefits of a modernization project. For the third and the last point, we are going to see how to move forward and actually modernize your data lake by discussing a migration approach and a roadmap. So let's get started. What is a data lake? A data lake is a repository for structured, semi-structured, and unstructured data produced in any format. It can be of any size and at any scale. It remains, however, important for your data to be retrieved and analyzed easily. So let's visualize this data lake together. What does it look like? As you can see on the screen, the data can come from various sources. It can be enterprise applications, digital assets, it can be sensor data, it can also be data that is streamed as events or also data produced by your business users. All of those sources can reside anywhere. They can be on premises or hosted by a cloud provider, also produced by a mobile IoT device, in the sense that the device changes location permanently. It is heterogeneous data in the sense that all of the data that is consolidated in the data lake comes from various sources and it is ingested with respect to various approaches. So when we consider the ingestion and processing, this might be done in the form of batches. That is to say, a chunk of data is ingested and processed at a predetermined frequency. This can be every hour, every day, every week, or on demand. Or this ingestion and processing approach can be via a real time. So you're basically streaming the data and process it as it's arriving into your data lake. So on the right-hand side of this view, we have the data consumers, which are data warehouses. They can be analytics tool or artificial intelligence and machine learning tools dedicated for training and deploying models. It can also be just sharing data via repositories. So this is it about our data lake definition. Now that we have exhausted this point, we are going to move on to the second point and elaborate on the drivers of a data lake modernization project. Basically, why do you need to modernize your data lake? Let's move forward. So mainly because of 3 reasons. The first one is the data center exit. So your organization makes the strategic decision to move away from all on-premises deployment. Usually, the goal is to save cost on IT investment by switching from capital expenditure to operating expenses model. In this scenario, for a quick migration, you can go with a lift and shift approach. On the second scenario, you can target a resource-intensive workload and migrate it to the cloud. So the benefits of this one is the agility which will be provided by a cloud deployment. And among these, we can cite the auto-scaling, which ultimately will allow you to save costs while guaranteeing the performance of your environment. And finally, you might have noticed that your data lake has turned into a swamp. So a data swamp, what is it? It is basically a data lake that has ungoverned data. It has gotten out of hand in the sense that data becomes difficult to find. It is hard to manipulate, impossible to analyze, or it becomes the basis of inaccurate information. So as a result, you can no longer trust the insights that you derive from your data lake, and making the case for a return on investment on your data lake becomes hard to make. So at this stage, you opt for a fresh start with a cloud-native migration. So moving forward on the third point of our agenda, and basically we are going to explore how to modernize. And it's on this point that we will spend most of the time of this cloud coaching session. So let's go. In terms of roadmap, we basically have three options. The first one that you have on the screen, it consists in a replatforming. So you could replatform your existing current on-premises or any Hadoop cluster deployment, and you migrate this one to OCI Big Data Service. We are going to go into the details later on. The second option here consists in building up on the first approach. So basically, it aims at collocating your big data service resources with their cloud-native components that are available on the Oracle Cloud. So with this option, you will unlock new possibilities in terms of cost reduction, governance, observability, serverless compute, and infinite storage, among other things. And the very last option we are going to explore in this session is the re-architecting. So it consists in re-architecting. Basically, you're going to rebuild all of the data lake. Instead of targeting a quick and easy migration as in the option one, you will replace all of the Hadoop cluster with their cloud native equivalent. So there is no collocation anymore. So with this, you will improve your platform operational maintenance, the cost optimization, and the innovation as well, because you're now relying on cloud native services which are maintained by Oracle and continuously updated with innovative features. So let's move forward with the first option, the replatforming. So again, the goal in here is to have a like-for-like migration and also improve the workload by taking advantage of the managed services and scalability features that are available on the Oracle Cloud. So at the core of this approach is the big data service of the Oracle Cloud infrastructure. So big data service comes with various components that allow for a like-for-like migration. For example, we still maintain the version 0.9 of the Oracle distribution of Hadoop to guarantee a straightforward migration from your big data appliance, for example, to the big data service on the Oracle Cloud. So using the big data service, you now have access to a wide range of OCI compute shapes, allowing you for many things, such as a dynamic control of your cluster capacity and resources, a customization of your cluster host to meet your workload requirement and suit your budget. On the third point, we can also cite the fact that it provides you with an infinite scalability for both the compute and the storage. Later on, we will see exactly which component this service is relying on. Another thing we can cite in here is the automation of all of the operations, such as the patching to reduce the operational and maintenance overhead for your teams. And another last point, after this one I'm stopping with the list, is that it will allow you to quickly auto-scale your cluster resources. It can be a scaling up or down, so vertical scaling, or also a scaling out or in with the horizontal approach to the scaling. One last information and promise we move on to the next one is that you can leverage the Fast Connect, the Oracle Fast Connect for a private subnet, to allow for complete high-speed access to your cluster and treat the Oracle Cloud infrastructure as an extension to your on-premises data center if necessary. So let's focus a bit more on the big data service and have a high-level overview of it before actually moving on to the OCI console and see what the service looks like. So the big data service is a cloud-based platform that allows organizations such as yours to process, store, and analyze large volumes of data. It uses the Oracle distribution of Hadoop to provide a secure and scalable environment for your big data workloads. So one of the key features of the big data service is that it supports the popular Hadoop components, including Spark, Hive, Presto, Kafka, etc. So this means that organizations can leverage a wide range of tools to access their data and extract valuable insights. Furthermore, the big data service is enterprise ready with features such as the Active Directory integration, the high availability, the patch management, having bootstrap scripts to kind of personalize your environment. We are going to see that later on. You have the options of providing auto-scaling features. You can integrate with object storage deployed on the Oracle Cloud, and also integrate with Kerberos for security features. So all of these features that we have seen that make your big data service enterprise ready will ensure that your organization can deploy the big data workloads with confidence, knowing that your data is secure and compliant and always available as well. So I'm going to move on to the console and actually explore this big data service. But before, these are the few elements we are going to double check into this console. So at the core of it, we see that we have the big data service. We are going to explore the compute shapes, the storage options, also check the various versions of the distribution that are available, and also the cluster profiles before moving on onto the various nodes that are available. So I'm going to switch to the console. I'm going to refresh my page to avoid being locked out. So how do we access our big data service? We go on the hamburger menu on the left and then choose Analytics and AI option. So under Data Lake, we have the big data service. I'm going to click on the big data service. So make sure that you are in the right compartment. In this case, it's my training compartment. And just to see how easy it is to deploy the big data cluster within the Oracle Cloud, I'm going to simulate it here. So basically, to be able to deploy your cluster, you will need to come prepared, let's say it that way. So you will need to provide a cluster name, the password that goes with it for your administrator. And where it actually gets interesting is already at this stage where you have this option to choose the type of deployment you want. Do you want it to be secure and highly available, basically for your production environments, or you want to go with something that's not highly available or with production level security that you require, for example, having Kerberos embedded. So namely, you can do this with non-production environments. However, in order to maintain consistency and not have surprises when you go in the context of your software lifecycle development, we will highly advise you to go with the same type of environment. So basically the production ready environment, which is secure and highly available. The next option is that you have to choose your Kerberos real name, and then another interesting feature here is the cluster version. As I have said previously, we are actually maintaining the Oracle distribution of Hadoop version 0.9 to simplify actually the migration from your current workload to the one that will potentially be running on the cloud. So actually we have today 3 options. We have the version 0.9, the version 1, and the version 2. And then another option here is the cluster profiles, which will help you, kind of tailor or customize the deployment with the profile of the workload, the big data workload, that you are going to run into your environment. So we have various options. We have obviously the Hadoop version or profile. We have HBase, we have Hive, there is Spark, Trino, and Kafka. So I will select Kafka here for the purpose of the demo. So moving forward, we have also the Hadoop nodes. And in here, we have basically 2 options. The first one is dedicated to the master and utility node. And so with a single let's say, configuration, you have these dedicated shapes for your master and utility node. And the secondary one will be dedicated to the workers node. So in here, the options we have are basically the virtual machine option and the bare metal option. The bare metal options offers you the possibility to have a dedicated physical server, and this is very good when you need isolation and performance. Otherwise, you could go with the virtual machine option, where you have a virtualization layer on top of it and you don't have to worry about the hardware anymore. So if we choose to go with the virtual machine option here, we can check the available shapes. So we can see that we have the standard shape, and actually the last number here is the amount of OCPUs. So for example, this one 2.4 is for 4 OCPUs. So again, if we focus on the VMs, you have the standard shape, which will be suitable for likely a general purpose workload. Otherwise, you have the flexible equivalent. And the difference with the standard option is that on this one, you can exactly choose the amount of memory you need. For example, just to name one example, I will actually check this just to show you. So you can choose the specific number of OCPUs you need, and also the amount of memory that you want to allocate to this specific shape. Or another option is to go with the dense IO, which is more suitable for your big data workloads, for example, or your large databases, because it comes with an allocation of locally attached NVMe SSD. So we will move forward. I will just pick this one, go forward. And then now we have again the same settings, but this one is dedicated to the worker nodes. So we will move forward. And then because I have picked the Kafka profile, I have this extra option, so a third one just for the Kafka profile, the Kafka nodes, and these nodes will be dedicated to run the Kafka brokers. And again, you have the same set of options. You choose the shape that is relevant for your workload, and then you move on to the network settings. In terms of this network setting, it's actually a private network that will be created, and it will allow for optimal communication between the different nodes of your cluster. And then moving forward, you have to choose a regional subnet, for example, and you have the option to have the quick start for your gateways, the NAT gateway and the service gateway, or you can choose to go with something that will be more customizable. And an important point following here is the encryption. So you can either choose to rely on the Oracle managed encryption keys or bring your own keys and actually specify your compartment where your key vault is, and also the master key encryption. Moving on, we have additional options such as the SSH public key that you can bring in here. So you either attach it as a file or just copy paste it. An interesting feature here is the bootstrap scripts, where you basically have a script. It will be a shell script that you deploy on or store on the Oracle Cloud infrastructure, and then pass the link in here. And basically in this file, you will have a configuration for your various components, for the various components of your cluster. So just to show you what it looks like, I have one here on the screen. This one is starting with the Ambari user, and it will actually tweak the component to the exact profile that you needed. And this one will be useful later on if you want to update this profile or the configuration. So I will cancel this creation window and actually show you what I already have deployed in here. So I have a cluster that is already deployed. You have in this screen, you can see the name of the cluster. We have the state of the cluster. Here it's active, the number of nodes. This includes the worker nodes, the master node, the compute only nodes, or even your SQL node if you want. And it also specifies if it's a high available and secure deployment. So in here it's the case. That's why it's set on true. You have the version of your distribution of Hadoop. So I will select this cluster, and we can get more information in here. So for example, I have the cluster profile that I have deployed. This one is based on a Kafka profile. And we have here the list of nodes that are deployed. So we can see that we have 7 of them that are active. I actually tried to add a Cloud SQL node here that has been, I have deleted it later on. And just to show you the high availability and secure approach of it, I'm going to consider these 2 utility nodes, and we will see how it's deployed. Again, before I go there, you have here on the top right hand side of the screen, you can see the region where I have chosen to deploy this cluster. And just for your information, my tenancy primary region is Frankfurt, but we have subscribed to additional regions. And in this case, we have various of them, but I have chosen to deploy my cluster in Amsterdam. So I'm going to see how this high availability is reflected within my deployment. So considering this first utility node, I will check where it's deployed. So again, we can see that it is deployed in the first availability domain of the Amsterdam region, and it's taking advantage of or just being deployed in the first fault domain. So going back, I will check the second utility node and see actually where it's deployed. So it's still the same region, it's the same availability domain, and finally we can see that it's deployed on the fault domain too. So with this approach, you have the high availability that is embedded into the deployment. So how does it work? For your region which has multiple availability domains, it will take advantage of these 3 availability domains. Otherwise, if it's a single availability domain, it will rely on the fault domains. So other things to consider here is that you can add nodes. So after your initial deployment, because my cluster is active already, it does not stop there. You can still add extra nodes. So that is basically the horizontal scalability. And you can choose on which type of compute you are going to add, either worker node, the edge node, or the compute only worker. You again have all of the flexibility. You can add the nodes here. It's based on the initial settings. You have to provide the password as well, and you can also add block storage to your various nodes that are already deployed. I'll cancel this one. We also have extra options, the Cloud SQL, for example. So just at the click of a button, you can add a Cloud SQL node, which will allow you to basically query all of the data that resides within your cluster. You could rename your cluster. An interesting feature that we have seen. So here is the add Kafka. So let's suppose that initially with the profile you have chosen, there is no Kafka deployment. Later on, you can choose to add the Kafka nodes, and your Kafka brokers will be stored in there. So again, you have all of the flexibility offered by the Oracle cloud infrastructure in terms of compute, and choose exactly the compute that is more relevant to you. So again, we have the standard offering, we have the dense IO, and something different here or additional is the possibility to do high performance computing as well. So leaving this one, cancel. So basically this is it. An extra thing to mention in here is the cluster URLs. So basically you can see that here we have Ambari, we have the URL. However, this URL is, let's say it's private because your cluster is deployed in a private network. So if I try to open it from the public internet, it's not going to work. Because I have this one to show you. There is a way to actually allocate private IP addresses to your cluster or certain compute nodes to be able to access them via the public internet. So again, I go back to my hamburger menu on the left-hand side of my screen, select networking, and then as part of the IP management, I can check the reserved IP addresses. So basically, to go to my node, I will consider this public IP address. And Ambari is actually deployed on the utility node 0. So here I I'm already connected, so you can see I have access to this Ambari component from the public internet. So basically this is it about what I wanted to show you on the OCI console, and I will go back to my presentation. So before moving on to the second option in terms of this migration approach or the modernization approach. So just for recall, we have 3 options that we are going to explore today. Before moving on to the second option, I would like to share a few words about how to migrate actually your big data services from your current deployment of your Hadoop clusters. So again, as said before, the big data service makes it easy for your organization to migrate your big data workloads to the cloud, to the Oracle Cloud, using a service such as OneDisco and a combination of, let's say, Hive metadata and distributed copy. So these services enable your organization to migrate your data seamlessly without disruption and by reducing the downtime and also increasing the productivity of your team. So the actual migration happens in three main steps that you have on the screen. The first one consists in backing up your big data appliance or your big data service or any Hadoop cluster, really. You back this data and metadata to the Oracle Cloud Object Storage. On the second option, you will do exactly what we have just shown on the screen. So basically, you will create your big data service cluster on the Oracle Cloud infrastructure. Again, you can take advantage of this flexibility in terms of choosing the specific shapes for the various nodes that you will deploy. You can take advantage of the profiles. You can use the bootstrapping to just automate all of the work that is there to be done on this cluster. And on the last step, you will just restore the backup that you have done in the first step within the big data service. So moving forward, we are now going to go onto the second of our options. So the second option consists in the refactoring. So while refactoring your workload, you will consider two things. So for example, again, it builds up on the first option. After you have migrated to the Oracle Big Data Service by going with a like-for-like migration, for example, now you are going to try to explore the limits of this new environment. For example, because it allows you to collocate some cloud-native resources and so on. So things you can consider are the following. For example, you can augment with additional capabilities and start moving gradually the data lake to object storage. So in fact, the OCI, the Oracle Cloud Infrastructure, offers some HDFS connector for your object storage. And this will allow your Apache Hadoop application to read and write data that is stored in object storage. You could reassess your use case by considering, instead of using, let's say, Apache Spark within your big data service, you could instead position Oracle data flow. So because of the first consideration, namely, the ability to use object storage, it unlocks new possibilities. For instance, using data flow, which is a serverless Spark. You could also position a tool such as OCI data integration, OCI data science, the autonomous database, for example. And with this approach, you will continuously embed all of the innovation that comes with the Oracle Cloud Infrastructure, cloud native components within your specific big data workload. And another point to consider here is that over time, you will end up having most of your jobs running in a cloud native or serverless environment. And you can think of decommissioning the big data service cluster. So you can see that with this phased migration strategy, you mitigate the risk, and actually it allows you to have the time to decommission your cluster in all security and without risk. So moving forward, in terms of the big data service, as we can see, it can natively integrate with other tools of the Oracle data platform. So namely, we can cite the object storage, for example, with the HDFS connector. You can also consider integrating it with the OCI data catalog by the externalization of Hive meta stores. You could also position OCI data science for your machine learning workload. This one is very robust in terms of training your models, because you can choose the exact specific shape you need just for the time of training your model. For example, after you can remove this compute capability, you have the options to go with GPUs. I will come back to this later on. I have a slide that is dedicated to the data science. You could also consider, as another option of integration, is to consume the data that is stored within your big data service cluster with the Oracle Analytics Cloud. And overall, we can see that the big data service is enterprise ready. So again, you have the security and management features, which include Kerberos deployed out of the box with the high availability option and secure option. It also integrates with the Active Directory. You have the high availability configuration for the production environments, the auto scaling, which represent substantial savings in terms of cost and operational overhead. because you don't basically need some engineers to actually do that. It can just be set up into the configuration and it will be handled automatically. Having the bootstrap scripts to customize your cluster will also save you some cost and also make sure that at any point in time your various environments and all of the nodes of your specific cluster always have the same profile or the same configuration. An important point here to note for the enterprise-ready features is the patch management. Because you do not have to deal with it yourself, you're actually saving time and also making sure that at any point in time, your environment is deployed with the best, let's say the best practices in terms of security, because it's always patched. So moving forward, we are going to see some examples of the cloud native services that you could collocate with your big data service. So again, we are in the option 2, the replatforming. So we are going to explore the various tools that you can collocate. The first one, which is really at the core of the data lake modernization, is the Oracle object storage. So the object storage is an internet scale storage layer, which is cheaper than the block storage that you will typically find within your big data deployment, because it uses block storage, for example. And object storage offers up to 3 tiers storage. You can have the standard storage, you have the infrequent access, and the archive. So basically, the colder the data is, so the less frequently you have to access it, the cheaper the storage is. So just to name a few examples, for instance, for your standard tier, you could choose to store the active data. So basically the data that you need to process either in real time or in batch mode, the data on which you will run analytics. And moving on, you have the infrequent access. So this one, you could consider it for backing up your data and metadata, and you can consider it for disaster recovery, for example. And finally, the last tier is the archive storage. This one for more long-term data retention, and the data is always accessible in the sense that you can always restore the data. So again, this one is a very robust storage area in the sense that in terms of durability, it comes with the 11 nines, for example, which basically means that in terms of probability of data loss, you have one in less than a million objects. So the probability basically of losing a data is 1 out of a million objects in a 10-year timescale. The second product that you could actually leverage in terms of this replatforming approach is the OCI data flow. So what is the OCI data flow? It is a fully managed Apache Spark service that performs processing tasks on extremely large data sets. And with this, you don't have an architecture to deploy or to manage. Another interesting point we can cite about the OCI data flow is that it offers an easier cluster management. So you don't have a cluster to install, to patch, to upgrade, and it will save you time and operational cost for your projects. It offers you a simplified capacity planning because it's completely cloud native. It will adapt to your specific workload. You don't have to plan everything ahead. Another interesting point is the continuous processing with Spark streaming. So it offers Spark streaming to perform your continuous ETL workloads. It's also integrated with the OCI data integration. So we will see it next. And the OCI data integration is basically a graphical user interface based ETL tool that simplifies complex data extract, transform, and load processes into your data lake and your data warehouses. So as you can see on the screen, it's completely graphical, but you have the option to add some codes, basically SQL codes, for example. An interesting point about the OCI data integration is that apart from being integrated with the object storage, for example, it also integrates with your OCI data flow. So all of the code that you have stored in data flow or that you're executing to process your data, you could embed this in the OCI data integration because OCI data integration also comes with an orchestrator. So you have a pipeline orchestrator where you can have your ETL data integration processes, but also based on a user interface, but also you can call those which are based on the code deployed within OCI data flow. So basically, again, just for recall, you will use OCI data flow to replace your Apache Spark components. Another tool here, interesting, is the OCI Data Science. So again, what is it? It's a fully managed platform for your teams of data scientists. It will allow them to build, train, deploy, and manage all of the machine learning models using Python and open source tools. So an important information here is that it's based on Jupyter Lab. So usually your data science team will not be lost. It offers an end-to-end data science lifecycle management from the training the model to deploying the model. And it will also allow you to detect some model drifts. As part of the offering is that you have flexibility in terms of compute. Because, for example, let's say you're working on an image detection model, you can just choose some GPU-based shapes, train your model, which will be faster. So after you finish training this model, you can shut it down and deploy the model on another instance that will consume less. So apart from the OCI data science that you could consider, you also have the OCI data catalog. So the data catalog, again, we have seen that it integrates with Hive and the Metastore, and it will offer you a visibility on all of your data that is stored in the Oracle Cloud Infrastructure. I mean the native offerings, for example, the autonomous database, the object storage. You can also have visibility of your data that is residing within the cluster of your big data service. Another option here is that the OCI data catalog also integrates with your Oracle databases deployed on premises. So this will really offer you a 360 visibility on all of your data, be it in the big data service, on the Oracle Cloud Infrastructure in general, or even deployed on premises. The next tool we will consider here is the identity and access management. So again, this one, as we have seen, it will allow you to actually manage the authentication and authorization necessary to manage all of your data platform. And because you have an integration actually between OCI and the big data service, you will have just a central point where you can manage the security of all of your deployment on the Oracle Cloud, and you can also integrate with other services because the big data service is today integrated with Active Directory. So as you can see on this screen, you have various cloud native components which integrates natively with the OCI identity and access management. And as part of this, we can cite the data integration that we have seen before. We have the object storage mentioned also before, the data flow features, the Oracle Analytics, you have the Oracle databases, you have the OCI data science feature, and also the OCI streaming, which is based on Kafka. So it's Kafka, but managed by Oracle. So again, a cloud native option that we highly encourage you to reuse in terms of this second option of replatforming your workloads. So now we are going to move on to the third and last of the migration approaches that we are exploring in this cloud coaching session. And the whole idea behind this re-architecting approach is that you will not collocate components which requires a management effort with components that are serverless or that are cloud native when the equivalent is available. So basically, we are going to see what the Oracle Data Platform looks like. And we refer, so just to, to clarify this, we refer to the data platform also as the data lake house, because it combines the best of the data lake and the data warehouse. So the first one, the data lake, because of its cost effectiveness, namely because in the storage area, for instance, and its elastic nature. And the second point is because of the data warehouse ability to be user-friendly, in the sense that it's a controlled environment, the data is benefiting of high data governance, which is enforced at any point in time, and you have some form of reliability, you can trust your data. So here I'm going to give some capabilities of the Oracle Data Platform. So the first one here that I can cite is that you have a seamless data and information usage without the need of actually replicating data across the data lake and the data warehouse, because these two will actually work together. So your data warehouse will be able to access all of the data stored within your data lake without making copies. And your data warehouse can also provide data to your data lake. If necessary, it can extract this data as copies. Otherwise, it's not necessary. The two are completely tightly integrated, and one can read from the other. And again, on the third point, you have the data catalog, which gives you access to both of them. So let's say you are a data steward, you have access to both, and you know exactly what is your data assets looking like. On the second point, we can cite that you have diverse data types which are supported, and this one will enhance your multi-model and polyglot architecture. In terms of governance, you have a fine-grained data security that you can enforce, and this one will leverage the zero trust security model of the Oracle Cloud Infrastructure in general. We also have the ability to fully decouple the storage and the compute, and this is highly important in terms of scalability. For example, if you need any resource, you can just increase it, and you don't have this tight integration between the two. Another point is that you have the possibility to leverage the multi-compute engines that are provided, and this one will allow you to achieve data repurposing, data liquidity, and also an increased usage. So again, you should use the OCI native cloud native services whenever it is possible, and this one will at any point in time help you reduce the cost and also the operational overhead. It offers you better economics because of the auto scaling feature. So we have seen you can scale in and out, you can scale up and down. It is interoperable in the sense that it's based on open standards. So any cloud provider or basically any system that adheres to those open standards will be able to communicate with this infrastructure that will be deployed on OCI. It also supports a diverse set of use cases, including the streaming ingestion, the analytics, data science, machine learning, sharing the data. And finally, there is different architectural approaches. You can go with a centralized lakehouse, or you can have a decentralized approach, which will look more like a data mesh. So these are the advantages of re-architecting your whole big data workload and go from, let's say you have an on-premises deployment to a fully cloud native solution. It will take time or require effort in terms of re-architecting, but you will save obviously because you have less components to deploy, or at any time you have the serverless option that is deployed. So this is it for today's session. Thank you very much for tagging along with me, and I hope the session was useful to you. And before closing, don't hesitate to reach out, and you can contact us via the two links that you have on the screen. So until next time, thank you very much.